Guys, welcome back to TechDose, and in this video we will look at longest adjacent group subsequence 2 problem, which is from Leetcode number 2901. A prerequisite before watching this is to learn longest increasing subsequence. So I have already made a detailed video from basic and the link will be present in the description below, so please go there and watch. Let's now start. You are given a string array words and an array groups, both arrays having length n. The Hamming distance between the two strings of equal length is the number of positions at which the corresponding characters are different. So if you have ABC and BBC, then if you check the corresponding characters, then at only one position they are differing, so the Hamming distance will be equals to 1. You need to select the longest subsequence from the array of indices from 0 to n minus 1 such that the subsequence denoted as I0, I1 and so on till ik minus 1 having length k follows the following two conditions. So the first thing is for adjacent indices in the subsequence, their corresponding groups are unequal. This must hold true. That means if you are including BAB and CAB in the subsequence, that means after BAB we are including CAB by excluding the item DAB, then the group of this BAB and CAB must be different, and this is true in this case. If they were same, then they cannot be included. This is condition number 1. Second condition is words at ij and words at ij plus 1 are equal in length. That means if you are including CAB after BAB, then they must be equal in length. Then the third condition is the Hamming distance between them is 1. So if you check all the corresponding characters of BAB and CAB, they are matching at two positions but not matching at exactly one position, and that is what the Hamming distance says. Hamming distance here must be equals to 1, right? So there are three conditions. The first condition, which says was the group must be same, group must be equal. The second condition was about the length of the two strings must be equal. The third condition was about the Hamming distance between the two strings must be equal. And these two strings which I am talking about are only the adjacent subsequence items, not the adjacent words. Okay, so in this entire array, if you have selected the first word and the third word in the subsequence BAB and CAB, then I'm talking about just the two adjacent items in the final subsequence. If you had another item AAB as the third item, then I'm talking about the CAB and the AAB. It is just talking about the adjacent item. So if you think that BAB and AAB should also follow because they are in the same subsequence, then no. This condition is only for the pair, the adjacent pair. Okay. So I think if you look at the problem number 1, in this case we have 3 items, and if you try to follow this entire approach, then you will be able to form BAB, DAB as one valid sequence because they have same length, the Hamming distance is 1, and also their groups are different. So this will be valid and this will be of length 2. And you can also form BAB with CAB because they have different groups, they have same length and their Hamming distance is equals to 1. So this is also valid. So both of them are of maximum length. So you can return any one of them and the output has BAB, CAB. You could have also written BAB, DAB as well, right? So I think the problem statement is clear. And if you look at the constraints, then the word's length is same as the group's length, which is n, and the n maximum value is 10 to the power of 3. So if you write an n square algorithm, it is going to pass within 1 second because this is less than 10 to the power of 8. Each of the word length is only 10. Now let's see about how to find the longest subsequence in this case. Now if you remember the longest increasing subsequence, we had the condition that when you include b after a, then b's value must be greater than a and b has to be on the right hand side of a. This was the condition, right, in the increasing subsequence. Now in this particular problem, it is having a different set of condition, but again we are trying to find the longest subsequence, not an increasing one, but based on 3 conditions which we had seen, based on the adjacent groups not being same, based on the adjacent Hamming distance should always be 1, and based on the adjacent items must always have the same length. If this 3 condition passes, instead of b being greater than a, if you just replace this condition with these 3 conditions, then it is the same problem as the longest increasing subsequence. So while solving this problem, I will be using the name as LIS. In this case, we are given the groups and the words of the same size, and I have taken 4 size, and I will also be taking the LIS array of the exact same size, as you know. Now LIS at all these indices have been filled by 1, because at least you can include one item. Even if you don't include anything, you can just include a word and say that it is longest subsequence of length 1. Length 1 is always possible, right? Now I have to consider if I write LIS at I equals to x. Like, let's say if I write LIS as 2 is equals to x in the final subsequence, then this means that if I had included this second item, which is ABB, as the last item in the LIS, then what will be the final length? The final length will be x. So in this particular problem, you will have only ABC on the left hand side. When I will solve it, you will see ABC will only be on the left hand side. So the LIS ending at index 2, including the second index item, will be of length 2, and so the x value will be 2 here, right? So that is what I have written here. LIS at I is the LIS ending at index I, where the words at I is included as the last item in the given LIS. Okay. So that is the meaning. Now if you think about where will the LIS actually end, where will the final answer end? The final answer can end at any point. It can end at index 2, it can end at index 3, it can end at index 1 as well. It can end anywhere. Okay, so in order to know what is the maximum length, you can take an LIS length as a variable and start tracking, or you can just avoid it, but after you have updated the LIS array, you have to parse it and see whatever is the maximum element, that will be your LIS length, isn't it? So let's see. In this particular case, I will be starting with the I loop. So the I loop will start from index 0 and it will go till the second last index, and this will always mean that the ith item is the second last item, and j loop will start from I plus 1 and go till the end, and this will mean that the jth item is the last item. Now if you try to make jth item as the last item and ith as the second last item, this means PQR has to be appended after ABC. So is it possible? Well, they are belonging to different groups, that is fine, but their Hamming distance is 3. ABC, PQR, they are differing at all the corresponding position. So since their Hamming distance is not 1, this first index item cannot be appended after the 0th index item, and we have to check for the second index item. Now you check, can ABB be appended after ABC? So if you see, the groups are different, and the length is same, and the Hamming distance is exactly 1, so yes, it can be appended. So even if it can be appended, I have to see if I am actually getting a larger length than any other subsequence, because what may happen is at index 2 you may have one length here which is saying 3 length, and another length might be coming here which is saying 2 length. So out of these two sequences, which one will you choose? You will choose the longest one, right? So already known length at this index 2 is 1, and if you see, if you append this ABB after ABC, then already at ABC ending is 1, so it will increase the length by 1 if you add ABB at the end. So the length is becoming 2, so I'll be updating this to 2, and so the LIS length becomes 2 here, the maximum LIS length, right? So that is the logic. Now I'll check with PQQ. The groups are same, so I will not care about it. Now once we are done with it, then my I will become will go to this index 1, and now I will be checking from the next index. So can ABB be appended after PQR? If you check, the groups are same, so they cannot be appended. Now PQQ, can it be appended after PQR? The groups are different, and the Hamming distance is 1, and the length is 3. So yes, they can be appended. And now you see, if it is increasing our length, so length here is 1, 1 plus 1 is 2, so this will be 2 here. Now since this 2 is not greater than 2, it will not get updated, right? And once we are done with it, then again my I will be starting from this index 2, and the j will be starting at index 3, I plus 1. Check it out. PQQ, can it be appended after ABB? They have different groups, but their Hamming distance is 3. It is not 1. So they cannot be appended. And now we are done. I will not go to the last item, because after the last item, there is no other item, right? So the last item cannot be the second last in the subsequence. So the LIS length is 2. We have found the LIS length successfully. Now my question is, how to get the LIS string? Well, you can get the LIS string by parsing from right to left. and you know what is the expected length, and you can form a list here. Let's say the LIS list, okay, the final LIS. So once you move from right to left, whenever you see the same value, this means that the subsequence ending at this index 3 has a length of 2, and you know that the longest length is also 2. So this means if you start taking this item, then whatever sequence it forms, it will definitely be one of the longest one. Since you know that there can be multiple answers, I just have to return one of them, so this approach is fine. So I'll be putting PQQ, okay, including it into the subsequence, and I will decrease the LIS expected length to 1, because let's say in this case, if PQR comma PQQ was the answer, then the LIS ending at this point will be 1 and here it will be 2, right? That is why if you move from right to left, the expected value, if you have included PQQ, the previous item should have LIS value 1. So that is why I am decreasing the value here. Now at ABB, you check the value is 2, which is not equals to expected. If you go to PQR, then it is matching the expected value, add it here, and as soon as it becomes 0, then you stop. Otherwise, you go to the end of the array and then you stop, because nobody will be having 0 value, right? Now you reverse this, and PQR comma PQQ will be the result. This is how you get the LIS, okay, the longest subsequence according to the 3 given conditions. Now there is a problem in this entire solution. What I can do is, if I just change this to PQR and if I change this to ABC, so I have just swapped the values, okay, and let's say I have also swapped the group, so this group is 2 and this group is 1. Now if you look at the increasing subsequence, then the final increasing subsequence will be 1, 1, 2 and 2, okay, it will be the same, there will be no difference, but the subsequence is ABC followed by ABB and PQR followed by PQQ. This is what the subsequence is. Now if you follow the exact same process of finding the LIS list, okay, finding the LIS list where your LIS length was equals to 2, and you move from right to left, then you see this 2 is matching with the LIS length, so you will include this PQQ, that is fine, and then you will decrease this LIS length to 1. And now when you go to the previous item, okay, this is 2 and the expectancy is 1, so it will not get included. This is 1 and this expectancy is 1, fine. So this means you will try to include this ABC, which is not correct, which is definitely not correct. You will stop here and say that ABC comma PQQ is the final answer, but it is not. ABC is from a different subsequence, okay, ABC, ABB is a different subsequence, and PQR and PQQ is from a different subsequence. But what we are doing is picking items from different subsequences will definitely be incorrect. It is not correct, right? And the problem actually happened because we are applying a very simple approach of moving from right to left and just believing on the counter, and this will not always give you the correct answer. Now the question is, how will you get the correct answer, right? How will you follow all the conditions? So if you had somehow remembered, like let's say this value is 2, but if you had also remembered in a pair who is your second last item, while building the entire LIS array, if this got updated by an ith index, right, if PQQ will get updated, then it will be updated, that means it will be appended only after PQR. So PQR being at index 0, if I can say that the previous item is at index 0 by saving it in a pair, then I can simply jump at index 0 and I will exactly be reaching to whichever previous item I actually want, rather than getting any wrong answer in the middle. So that should be my idea. Whoever is the second last item, that means whenever you update a jth item, always save either in a pair or use a extra space the previous item that has to be included, which was included. So if PQQ got included when the j index was here and the I index was at 0, then okay, you have written a 2 here, but you also write the previous index is at 0. Okay, so that after 2 you will reach to this index 0 and include this PQR as the second last item. I hope this is clear. So that is why I will be using a parent array. Now let's look at the dry run of our entire idea. So here I will be taking the groups and the words array of 5 size. So this is given as input, and I will keep track of all the three cases while doing the comparison between any pair of strings. I have taken the lis length and lis end value. So lis length will always tell what is the maximum length of the subsequence, and the lis end will say at what index the lis is ending. Okay. We also have an optimality condition where it says that if jth item has to be appended after ith item, then you better increase the length of lis, otherwise there is no meaning to appending the jth item after ith item, right? I will always be selecting the longest length. Now if you see here, the lis array has all 1 values. That means you can just include a single item and say that this is a subsequence, a valid subsequence, and so you can keep it of length 1. And if you look at the parent array, they all have -1 because there is no previous item to it. The parent array will be storing the previous item in your increasing subsequence. Okay. So I think it is clear, and let's now see the dry run. So I'll be starting my index I at 0, and index j will be from I plus 1 till the end. And see, can I include this BBC after ABC? So the groups are different. The Hamming distance is 1 and the length is same, isn't it? So I can include the jth item after ith item. So is it increasing our length? Yes, 1 plus 1 is 2. It is increasing our length. So since this first index item got appended after the 0th index item, so the 0th index item is the second last. So I'll be updating the parent of 1 becomes 0. Now the length of lis is 2. So length of lis increases to 2, and the lis end index is 1 because lis of length 2 is ending at index 1. Now I will check for AB. AB is of different length than ABC, so I'll just skip that. AAC, it is of the same length. They are belonging to two different groups and they have Hamming distance equals to 1. So this jth item can be appended after the ith item. That is true. And so if you look at it, the length here is 1, the length here is 1. So 1 plus 1 will be 2. Update it. And the third index previous item is index 0. Move on to the next item, BDC. If you see BDC, the previous item is ABC. ABC. This is BDC. So the Hamming distance is 2. So BDC cannot be appended after ABC. Okay, and we are done. Then I will be moving to the next index, and I will try to keep the first index as the second last item, and J will start at index 2. Now AB cannot be appended after BBC because they are of different length. AAC cannot be appended after BBC because Hamming distance is 2. Also their groups are same, right? Then BDC can be appended after BBC because their Hamming distance is 1, their length are same, their groups are different. So if you do that, the length of lis ending at index 1 is equals to 2. Okay, is equals to 2. So it will be 2 plus 1, which will be 3. Now this 4 got updated by 1. That means its previous item must be index 1. So here you have to write index 1. You have seen a larger lis value, so the lis length will be increasing to 3 and your lis end index will be updated to index 4. Okay, I suppose this is clear. Now we will be updating our ith index and I will be going to AB. Now for AB, none of the items can get included because this is of a different length. So I will be going to the next index, which is 3. So for this one, the J will be starting at 4, and if you check it out, the Hamming distance is 2, so they can never be included. And now since we are done with the second last item, we are done with the process. Now we can look at the lis length, and it says that 3 is the length of the longest subsequence according to our 3 given conditions, and the lis end index is 4. That means at 4 only the lis is ending. Fine. So if I have to get the lis subsequence, okay, if I have to get the final list, then I will go to lis end index, which is this 4. Okay, include this 4, which is BDC. BDC will be included. Now this parent at 4 will tell us what is the next index to go. So it will say index 1. At index 1 you have BBC, so include BBC. Now the parent at 1 will say what is the next index to go to. It is 0. So 0 means you have to include ABC. Now at 0 you have -1 value. That means there is no previous index and you are done, and the reverse of this is the result. Okay, this is how you will be finding the result. Now let's say in the lis you had got lis as 1 2 1 2. this was the LIS. Okay, if I just include the exclude the last item, then this would be the LIS 1212. So in this case, the LIS length would be 2 and the LIS end value will be index 1, 0, 1, 2, 3, index 1. Okay, so according to my assumption, I will always be updating the LIS length when I see a better result. Otherwise, I will be returning in this case 0, 1, right? But you can return anything, so it does not even matter. I hope this entire idea is clear. Now calculating the Hamming distance between two strings A and B, between two strings, is order of length of the string. So in this case, the maximum length is 10. So the time complexity here is we have to run two loops to apply the LIS logic. Okay, so this is n square, and for every pair A comma B, two strings, we have to check for the Hamming distance, and that will require 10 character comparisons at maximum according to the constraint. So if you consider the runtime, it will be 10 to the power 6 times 10, which is 10 to the power 7 computations, which is still less than 10 to the power 8. So this is expected to pass. And the space complexity is order of n due to the LIS array parent array. Okay. So I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the words and groups. We will find out the size of words, which is the same as the group size. I will be taking the LIS array of n size, all predefined with 1 value, the parent array of n size, all predefined with -1 value. Then I will be taking LIS length of 1, LIS end value at index 0. That means if you just had a single item in the entry, then my LIS length will be 1 and index will be 0, right? So that is my assumption. And I will be applying the longest increasing subsequence logic. The ith index is the second last item, the jth index is the last item, okay, as I have already explained. And I will be checking if the group set I is not equals to group set j, if the word size is same, if the Hamming distance is actually equals to 1. So I have written a function for Hamming distance, which I will show you. And if all these three conditions are true, then optimality condition, if 1 plus LIS at I is greater than LIS at j, then only I will be updating the LIS value. I will be marking the parent of j as I, because ith item is the second last item of the jth item, right? So it is on the left hand side. And if LIS at j is greater than LIS length, then update the LIS length and LIS end index. After doing this entire thing, I will be parsing the final LIS list from the LIS end value and move back and actually record all the words and reverse the entire string and return it as the result. If you want to see the Hamming distance check, then taking two strings A and B, starting with the Hamming distance 0, just go one position after another, and if the characters do not match, increase the Hamming distance and record it and return the final corresponding mismatches. So this is the entire code, and I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.